Hello, this is Pavani, Assistant Professor in IT Department at SMRT. We are going to look into Database Management System CC 3492 Unit 3. Construct queries to handle transaction processing and maintain consistency of the database. Unit 3 Transaction. Okay. The introduction to transaction part. Okay. Transaction in DBMS is a logical unit of work that performs database operation. It may consist of one or more read and write operations. Actually, transaction in DBMS is a sequence of one or more database operations such as insert, delete, update, or select. Execute as a single logic unit of work. Okay. Transaction ensures that database remain consistent and reliable. Even in case of system failure, power loss, or multiple user accessing data simultaneously. Okay. Transaction ensures data consistency and integrity. They are executed as a single unit. If any part fails, whole transaction is rolled back. Okay. Transaction follows some specific properties. These properties guarantee reliability. They are fundamental to database system. Let us tell you a simple definition. It is a program execution that reads the data, modifies the data, and writes data back to the database. It must completely, entirely, or not at all. Example C. Consider a bank money transfer. Debit 1000 from account A, credit 1000 to account B. Both steps must have happens together. If one step fails, the entire transaction must be cancelled. See, transaction states like active, partially committed, committed, failed, and aborted. Active state, transaction is executing, partially committed state, final statement is executed. Committed state, successfully completed. Failed state, cannot proceed. Aborted, rolled back. It undo changes, okay? Then moving on to transaction concept. Transaction begins with start statement. It performs several database operations. The operation may include same select, insert, update, or delete. After execution, it ends with commit or rollback. Commit saves changes permanently. Rollback undoes the changes. Transaction maintain consistency. They protect data from errors. Transaction in DBMS sequence of database operation performed as a single logical unit of work. It ensures the database operations are executed completely and reliable even if failures occurs. Okay. Basic transaction operations will be begin, start transaction, commit, save changes permanently, rollback, undo changes, save points, set a checkpoint inside transaction. Moving on to states of transaction. Transaction has a multiple state. Active state is when it is executing. Partially committed state occurs after last statement. Committed state means successful completion. Failed state occurs when error happens. Aborted state rolls back changes. Terminated state ends execution. These states manage transaction flow. Moving on to asset properties overview. Asset properties define reliable transaction. ACID stands for atomicity, consistency, isolation, And durability. Atomicity is all or nothing. If any part fails, entire transaction is rolled back. Consistency. Database remain in a valid state before and after transaction. Isolation. Transactions do not interfere with each other when executed concurrently. Durability. Once committed, changes are permanent even after system crash. Moving on to brief of atomicity. See, likely I said it means all or nothing. Either all operations execute fully or none of them are executed. Partial updates are not allowed. If failure occurs, rollback happens. Ensures data reliability. Managed using logs prevents incomplete transaction. Okay. Then moving on to consistency. It ensures valid database state. After transaction completion, constraints hold true. Integrity constraints must not be violated. Database moves from one consistent state to another. Invalid data is not permitted. Rules and triggers maintain consistency. Foreign keys are checked, ensures the logic correctness. Isolation. It prevents interference between transactions. Concurrent transactions should not affect each other. Intermediate results are hidden. Appears as if transaction runs serially. Controlled by concurrency control method. Prevents dirty reads. Avoid inconsistent result. Maintain execution independence. Moving on to durability. It ensures permanent storage of changes. Once committed, data survives system crash. Stored in stable storage. Recovery mechanism protects data. Log files are maintained. Ensures reliability after failure. Committed data cannot be lost. Provides long-term persistence. Moving on to schedules. Schedules is order of transaction operation. It shows sequence of execution. Multiple transactions may interleave. Schedules help analyze concurrency. They determine correctness. Can be serial or non-serial. Used in concurrency control. Ensures consistency maintenance. Moving on to serial schedule. It is nothing but a schedule in which transactions are executed one after another without overlapping. That means one transaction completes fully, then the next transaction starts. Example C, consider two transactions. Transaction 1, read A and then write A. Transaction T2, read B and then write B. Serial schedule T1 followed by T2. Make a note of it, okay? If T1 is read A and T1 is write A, T2 is read B and then T2 is write B. Here T1 complete first. T2 starts only after T1 finishes, okay? See, non-interleavation occurs, maintains consistency easily, simple to implement but reduces concurrency, not efficient for multi-users, safe execution methods and guarantees correctness. Advantages of serial schedule will be simple execution, no data inconsistency and no concurrency problems. Thank you.